In this video, we're going to talk about an incredible time-saving shortcut. So first of all, we need a slightly broader view. As a general rule, we've talked about the complement rule already. This complement rule can sometimes be used as a shortcut in some problems. In some of the later videos, we'll talk about this more broadly, using the complement rule as a shortcut. And I'll say right now, ordinarily, the hard thing about using it as a shortcut is recognizing that one could do this. We read the problem and then we have to have the insight, oh wait a second, maybe it would be easier, instead of calculating directly what they're asking, to calculate the probability that it doesn't happen and then subtract that from 1. So once you recognize that, then the complement rule will save you time, but you have to have that recognition. Well, here I'm going to show you one case where that recognition will not be a problem. There'll be an automatic clue, and 100% of the time you can use the complement rule as a shortcut. So that's what makes this such an efficient and powerful shortcut. Here's the big idea. When you see the words "at least" in a probability question, use the complement rule as a shortcut. Now, in particular, whenever the words "at least" appear on the test, it is almost always part of the phrase "at least one." This is a huge advantage for us. Now, why would this be? Let's think this through. Suppose there are 6 trials of something. We're rolling 6 dice, we're flipping 6 coins, something like that, and we want to know the probability of at least one success. Think about the number of successes. Suppose I'm flipping 6 coins. How many heads could I get if I flip 6 coins? Well, theoretically, I could get anything from 0 heads, if it were all tails, up to 6 heads, all heads. Now, of course, these are not all equally likely, but all of them are possible. So what would be the set at least 1? So at least 1 would be 1 or more. All of these are at least 1. We could say this box here, that's the set at least 1. Well, what's the complement of that set? What's the part of the set, the whole set, not included in that box? Well, of course, the complement of that is just 0. And that is always the only case that is not included in the phrase "at least one." So this is a huge idea. The complement of at least 1 is none. And therefore we can say the probability of at least one success is the probability of 0 successes. So instead of having to figure out a bunch of different probabilities, which is what we'd have to do if we figured out directly, we can just figure out one probability, often a very, very easy probability to figure out, the probability of something happening no times at all, and figure that out and subtract it from 1, and we're done. So I'll show you a couple examples of why this is so powerful. Suppose we have this problem. This is a very hard problem. Suppose we roll one fair 6-sided die 8 times. What is the probability that we will roll at least 1 6? So let's think about this. We have 2 choices. We can do sort of the completely straightforward method of solving this. And as you'll find, that route will be very, very time consuming. Or we can use the shortcut. So first, just so you appreciate how much time we will save, I'm going to show you this more lengthy, straightforward method, so just so you get an idea of what's involved with this. So, the standard solution, the condition at least 1 6, includes 8 cases. We could get exactly 1 6, or we could get more than 1 6. So any of the numbers from 2 through 8, these are also included. These are the number of dice that could show up with a 6 on it. And again, these are not all equally likely, but it doesn't matter. All of these are possible cases. Each one of these 8 cases is a binomial calculation. So that means we'd have to do 8 different binomial calculations. So we'd have to do all these calculations. Now, of course, in a problem like this, they're not going to give it to you in a nice form of all these things added up. You're going to actually have to go through a lengthy calculation, simplify all this stuff, put it all together as a number, and then choose from the numerical answers. So this calculation could take you, I don't know, 10 or 15 minutes. This would be a nightmare calculation. If you want to do it, go ahead. I'm going to show you a shortcut that's much easier. So here's the shortcut. The efficient solution, the complement of at least 1 6, is 0 6s. Well, let's think about this. Probability of not getting a 6 on one roll is 5 over 6. The probability of that happening, of getting not a 6 8 times, is 5/6 to the 8th. And so the probability is 1 minus 5/6 to the 8th. Now you may have to calculate this, but it may well be that if it's a smaller number, of course, that you will calculate it. But something like this, 5/6 to the 8th, they're probably not going to ask you to calculate that. They're probably just going to write the answer in this form, 1 minus 5/6 to the 8th. So if you did it the forward way, you'd have to realize that you could simplify that whole mess down to something as simple as this. But it turns out the way we did it here, this efficient solution, we got there with almost no calculations. In other words, this was just a ridiculously easy way to get to an answer here. So, in summary, I will say, whenever you see the words at least in a probability problem, and especially when you see the words at least one, then you know automatically that the shortest and most efficient solution will be using the complement rule, using the fact that the complement of at least one is 0. Now again, in future videos, we'll talk about using the complement rule in more complicated scenarios. In the other scenarios where it would be a shortcut, there's going to be a problem of recognizing it. For this particular case, there should be no problem recognizing it. You'll see these words, and that will be the trigger. Automatically, you know you can use the complement rule as a shortcut.